this video we're going to try out an unusual preparation of ethyl iodide. The classic preparation covered in our other video uses iodine and red phosphorus. But we heard that it was also possible using iodine and aluminium metal. We're starting with 30 grams of solid iodine. We're placing it in the dry 250 ml flask equipped with a magnetic stir bar. And we're going to start off with 25 ml of ethanol to see how this goes. The stoichiometric amount we need for the reaction is about 14 ml, but we'll use an excess. Let's get this into the flask. Okay, now for our aluminium foil. We've got a layered sheet here which weighs 5 grams. This should be in excess of what given that 1 atom of aluminium should react with 3 atoms of iodine. We cut it into strips and then rolled into little balls so we can easily add to the reaction mixture. Here's our setup. We've got a flask on a stirrer, equipped with a big condenser for refluxing, and sitting in a bowl just in case we need to apply rapid cooling water. We have no idea how quickly this reaction is going to go, or how vigorous it's going to be, so we want to be on the safe side. We've got ice in the cooling water because ethyl iodide is quite volatile. Let's get started. Oops, one missed. We've got everything in there now, and place the condenser back on. There's no immediate fireworks, but we do notice that the mixture in the flask is warming up, and soon it starts to bubble. And we start to get a reflux going in the flask as the temperature rises. The iodine and aluminium are combining to form aluminium iodide, and this is a highly exothermic process. But in addition we have various reactions between ethanol and the aluminium iodide going on, and maybe even the reaction with the aluminium and ethanol. If there's one thing we've learned about iodine chemistry, it's that it is always more complex than you think. About 30 minutes in and we've got a pretty strong reflux going on now. This is the peak of the reaction. The aluminium is dissolving to form a dark brown sludge in the flask. At this point we switched the stirring back on to see if this would speed things up a bit. And we decided to add a little more ethanol to the flask, 10 ml. In addition, the reaction mixture bubbles and foams. But this seems to help the aluminium dissolve. The reaction flask kept refluxing under its own heat for nearly 2 hours in total. Eventually it started to cool, and as it did the reaction mixture frothed up like this in the flask. At this point we changed the setup so that we could distill the contents of the flask. We're going to distill all liquid, so we didn't bother using a thermometer. On heating, the foam soon dies down, and we start to get a clear liquid distilling, which to begin with we're assuming is excess ethanol. Distillation was fairly slow, and although a lot of liquid came off in the first 30 minutes, distillate continued to come off for several hours. We also noticed that the bottom part of the boiling flask turned into a white solid. For the last 30 minutes we used some foil to ensure that the flask was heated strongly. Even during this time there was a steady evolution of dense tiny pale yellow drops. These look suspiciously like ethyl iodide. Towards the end the distillate turned a darker yellow, and then finally died right down. We stop heating at this point. You can see the last bit of liquid was quite brown in color. The boiling flask at the end is filled with a shrunken cracked dark brown solid. On cooling, we broke this up and placed it into a dish out of curiosity. It's probably mostly aluminium hydroxide or oxide. We added some water, but there was no reaction and no exotherm, and the resulting water mixture is just slightly acidic to indicator. Here's our yellow-colored distillate. This hopefully contains some ethyl iodide and an excess of ethanol. We transferred this into a separating funnel. Then we made up a washing solution of strong sodium chloride in cold water. Ethyl iodide isn't very soluble, so the brine and cold should minimize loss. We added a bit of the washing solution to the funnel and then shook vigorously to get the alcohol to transfer into the aqueous layer. As you can see, 2 layers separated. Once separated, we drained off the bottom organic layer. We then discarded the aqueous top layer and returned the organic product back to the funnel for a second wash. And again, shook thoroughly and then separated off the bottom layer. We returned this to a clean funnel once again, and this time used the same washing solution but with a small amount of sodium bisulfite dissolved in it. On shaking, this gradually removed a lot of the yellow color from the liquid. We drained off the milky bottom layer. And then we added some anhydrous calcium chloride to this in order to dry the liquid. With a bit of swirling, this quickly produced a clear liquid, but still with a bit of a yellow tint. We transferred this into another container for weighing. Here's a crude product. 24 grams of what seems to be fairly pure ethyl iodide, although it does have a yellow color, and this doesn't seem to be due to iodine. This is a 65% yield from starting iodine. This is average, but the product is obviously not quite as pure as you obtain by using red phosphorus, or from ethanol, potassium iodide and phosphoric acid. But it was an interesting reaction and worth checking out. It takes a while though and is very exothermic, as you saw. So be very careful if you try to scale this up. Thanks for watching and stay tuned.